Okay, we're going to look at the reciprocal trig functions and being able to use them. So let's recall from our investigation with the unit circle and drawing the tangent segments what the trig functions and the reciprocals are. We're going to say that the trig function sine, I don't like this color. I like this color. Sine of theta is a reciprocal function with cosecant of theta. Cosine of theta is a reciprocal, and I won't say function to save a little space so I can fit it on one line. I just said I won't say it. Reciprocal with secant of theta. Tangent of theta is a reciprocal with cotangent of theta. Now, I'm not going to sit here and list what that means. There's so many possibilities of how you can write it. Just understand what reciprocal means. It means that you flip a fraction. So if sine and cosecant are reciprocals, one thing it means is that the sine of theta is going to be equal to 1 over cosecant of theta. Okay, so since they're reciprocal with each other, I can make an equality statement that says the sine is equal to the reciprocal of cosecant. Similarly, I could say that cotangent of theta is equal to 1 over tangent of theta. And because I can express tangent of theta as sine over cosine, this means a whole crazy other thing. So like if I know that tangent is equal to sine over cosine, then I know that cotangent is equal to cosine over sine, since they're reciprocal functions. It would be 1 over that. I know that it would be like 1 over that, 1 over cotangent, because that would be cosine over sine, and then 1 over cosine over sine would go back to sine over cosine. So there's all these crazy things that I know, and the ones that we use most often are things like this. We know that secant of theta is equal to 1 over cosine of theta. That's kind of the one, things like that involve cosine and sine that we use the most. Okay, so just knowing their reciprocals means that if I flip them, they're equal to the other one. So when I say flip, I know they're not fractions, but you can imagine them as like over 1, right? So cosine is going to be equal to, if I flip this one, cosine would be equal to 1 over secant. Or I could say secant is going to be equal to flipping the other one, which is what I did here. All right, so that's what it means to be reciprocals. And we're going to use these facts all over the place to figure out values. So here's an example. Using the reciprocal trig functions. If we want to find the exact value of cosecant of 30 degrees, right? Well, cosecant of 30 degrees, on my unit circle, I only have sine and cosine values. So it's going to help me to rewrite cosecant in terms of sine or cosine. And honestly, there's 2 ways to do this. So this is the first way. Cosecant is reciprocal with sine. So I'm going to say that cosecant is equal to 1 over sine. And now, since I rewrote this in terms of sine or cosine, I have only sines or cosines in it, I can use my unit circle. 1 over the sine of 30 degrees. Now, at this point, I'm hoping you can start to not need to have your unit circle, but you'll be able to understand it. To find sine of 30 degrees is that low, flat one over here. So I know the legs are different. The legs are either going to be 1/2 or root 3 over 2. So how do I decide which one it is? Well, I know the sine value is really the y coordinate, or this vertical line. And I know that when I have the low flat angle here, that's going to be the shorter leg of the 2. So that's going to be the smaller number. So it's 1/2. And so now, to simplify that complex fraction, I have 1 times Instead of 1 divided by 1/2, I have 1 times 2 over 1, so I have 2. That's one way to do it. Another way to do it is, since you know the reciprocal functions, to figure out what the cosecant of 30 is, I would first find its reciprocal, sine of 30. Find out what that is first. I should say first find. Okay, so the sine of 30, I just went through how to describe how to find that. We've pictured 30-degree angles as that low flat one. That makes the y value the shorter leg of the two, which means the sine value is 1/2. And then since cosecant is the reciprocal of sine, you can take your answer and just flip the answer. Right, so then you flip 1 over 2 and you get 2 over 1. So that means that the cosecant of 30 degrees is equal to 2. So you can kind of write the reciprocal function first, which is what I did up here, and then just kind of solve and simplify. Or you can find the value of the reciprocal function, which I did here first, 1/2, and then just flip the answer. So either place you're kind of flipping. I'm not going to say one way is better than the other, because in certain situations this way is better. So for this situation, I would have definitely done it this way, get the answer and flip the answer. But in other situations, it might be better to do something like this. So I'm not going to tell you one way is better than the other. I did want to go back here and mention, how can we remember which ones are reciprocals with each other? Since they're like flipping, I've heard students in the past say the sine and the cosine go to secant and cosecant. And if we look at the first letter, since we're thinking reciprocal is like flipping or sort of like opposite, we don't really want to use the word opposite because it's not what it means. But when you flip, you're kind of turning it upside down or taking the opposite. So the S1 turns into the C1, and then the C1 turns into the S1. So that's how we sort of remember reciprocals. They start with the opposite letter. And then tangent and cotangent kind of make sense because they're both dealing with tangent, like they're similar. They sound like they go together in terms of reciprocals. So it's not like a mathematical formula or any kind of theorem. It's just some tricks that I've seen in the past that students use to remember which trig functions are reciprocals of which ones. I personally like the pictures that I drew for you, picturing those similar triangles and building them that way. This way you never have to memorize anything. You just have to know those pictures, and then you can build and understand. All right, so we're going to keep going here. So find the exact value without using a unit circle. So the cotangent of 150. So again, we're going to think of, there's a bunch of ways to do this. I think the best way to do the cotangent one is, I know that cotangent of 150 is equal to cosine of 150 divided by sine of 150. All right, so what I want to do here again is I took this guy that's not on the unit circle. I know it says without using the unit circle, but I changed it to all cosines and sines because even though I'm not using the unit circle, I know how to find the values of only cosine and sine from the unit circle. So I always want to kind of change my function into cosines and sines. That's what I did up here as well, right? We changed it into sine. Whoops. We changed it into sine so we can find the value of sine. Or if we did it the other way, we said, well, we can find the value of sine first. The whole key is that really working with the unit circle, whether we have a picture of it or not, or if we work through it in our head, we really can only find the values of cosine and sine. So I'm going to change cotangent into that. And now 150 degrees. It says without using a unit circle, but I'm going to go ahead and draw it anyway and build through it. Eventually you'll start to memorize these values. So 150 means we've gone almost to 180 with our terminal side. Okay, so that's 150 degrees. So the reference or the triangle that's made is it's going to be a 30, 60, 90 triangle. So again, that's that low flat one. So I know the values are going to be 1/2 and root 3 over 2. So I just have to decide which leg is the smaller leg. Well, this leg's the smaller leg, the y. And then the x is the longer leg, and it's also going in the negative x direction, so it needs a negative. So now I know my cosine and my sine values. Remember, cosine is on the x-axis, sine is the y-axis value. So the cosine of 150, we know, is really the x value here. So it's negative root 3 over 2 divided by the sine, which is 1/2, 150. And now I simplify this fraction. Negative root 3 over 2 times 2 over 1. So then these cancel, and I get negative root 3. That's how you kind of work through it. Eventually, we may start memorizing a bunch of these values from our chart, whether we want to or not. It just sort of happens, and maybe we don't have to draw this picture out. But I really like this because it shows understanding, and I don't have to memorize much. All right, so how about to find the secant of 7 pi over 4? Well, I know secant is the reciprocal of cosine. So again, I have the two ways that I can do this one. I could write it out as the reciprocal here, or I can just find the value and flip the value. So in this case, I think it's easiest to find the value. I'm not going to say they're equal. I'm going to first find the value of the reciprocal of this function secant, cosine of 7 pi over 4. I think this is the fastest way to do it for secant and cosecant. Tangent and cotangent, I think drawing the circle out and calling it sine over cosine or cosine over sine is better. But for this one, I'm going to find the value of cosine of my angle and then flip the answer afterwards. So to find cosine of 7 pi over 4, if I take pi and break it into 4, so I got 1 pi over 4. Right. This is 1 pi over 4. This is 2. I'll draw it in purple so we can see. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. There's my terminal side. So I've got this triangle going on here. Since it's the 45-degree angle, both legs are the same. Let me see if I can zoom in here. So this leg is root 2 over 2, and this leg is negative root 2 over 2 because we're going in the negative direction. So that means this is the cosine, right? The x value, or the horizontal one's the cosine, and the sine is negative. So the cosine of that is going to be root 2 over 2. But we really wanted the secant, and since we know the reciprocals, I can just flip this answer. So this now becomes 2 over root 2. And now I don't want the square root of 2 in the denominator, so I have to rationalize. Oops. So I get 2 root 2 over 2. Those 2's cancel, so are reduced to be 1, so then I just get root 2. All right, let's look at secant of 3 pi over 2. Once again, the easier thing to do with secant is to just find the value of cosine and then flip it. So I know the cosine of 3 pi over 2 equals, so cosine of 3 pi over 2, if I take pi and break it into 2's, I have got 1 pi over 2. Oops, I'll do it in purple again. I kind of like that. I've got 1 pi over 2, 2 pi over 2, 3 pi over 2 right there. So if I draw that triangle, my unit circle, let me make that circle a little bigger so we can get our triangle in there a little bigger. So I'm at a 45-degree angle, so these are the same. They're root 2 over 2 and root 2 over 2. And remember, this one's negative. The x value one's negative because we're going in the negative direction. So maybe we could draw a little bigger circle here. We're over here at the 45. So this is negative root 2 over 2, and this one's root 2 over 2. Which one is the cosine value? Well, that's the x coordinate. So this is going to be negative root 2 over 2. And then since we wanted the secant is the reciprocal of cosine, so we flip it. So now we got negative 2 over root 2. Again, we don't want square roots in our denominator. So we're going to rationalize by multiplying the numerator and the denominator by root 2 over root 2, and we get negative 2 root 2 over 2. The 2's cancel. We get negative root 2 for an answer. Okay, let's look at cosecant of negative 120. Draw a bigger circle. All right, so negative 120 means I go in this direction, right? So 90, and then I don't quite go to 180. I go another 30 past that. So we're talking about right here. This is negative 120 degrees. So if I draw in my triangle, that's one of my 30, 60, 90s, where that's the big angle, right? It's like the tall, thin one, not the low, flat one. So I know my two values are 1/2 and root 3 over 2. So this is clearly the smaller leg here, so it's 1/2, and it's going in the negative x direction, so it's negative. And this is clearly the bigger leg, so it's root 3 over 2, and it's also negative. So I want the cosecant value. I know the cosecant is the reciprocal of sine. So the value of sine of negative 120, that's my negative root 3 over 2 guy. So now if I want the cosecant, all I have to do is flip that answer. So I should say first I'm doing this. Then I'm flipping my answer to make it negative 2 over root 3. Of course, we can't have roots in our denominator, so we have to rationalize by multiplying by root 3 on top and on bottom. That's our final answer. That is the cosecant of negative 120. Okay? Now let's look at when we have trig values that are not on the unit circle. I'll stay with green. So given that the sine of theta is 3/5 and theta is in quadrant 1. Okay, so theta, this angle somewhere in quadrant 1. We have to know that sine of theta equals opposite side over hypotenuse side. So when I draw this thing, I drew theta in quadrant 1. The hypotenuse is 5 because its sine is opposite over hypotenuse. And then the opposite of theta, which is over here, is 3. Because this is opposite and this is hypotenuse. This is clearly not on the unit circle because 5, the hypotenuse, is not 1. So now, like, if our unit circle has a radius of 1, the unit circle is somewhere down here. This thing goes well past our unit circle. So now we want to find the value of all 6 trig functions. So we want to know what's the value of sine of theta. We want to know cosine of theta. Whoops. I should put it in parentheses. Tangent of theta. Cosecant of theta. Notice I write the reciprocals on the same line. Sine and cosecant are reciprocals. The secant of theta. And then the cotangent of theta. I want to find all of those. So what this comes down to is just doing Pythagorean theorem here. So I need to find out what that missing side is there. So we'll call that side x. I do Pythagorean theorem, x squared plus 3 squared equals 5 squared. You'll get that x equals 4. How do I know that so quickly? Because I know my Pythagorean triples. 3, 4, 5 is a triple. So now that I have all the sides of the right triangle, I can make all my different trig ratios. So I know sine is opposite over hypotenuse. So opposite of theta is 3. The hypotenuse is 5. Okay? And we were given that one. Cosine is adjacent over hypotenuse. So adjacent to theta is 4 and the hypotenuse is 5. Tangent is opposite over adjacent. So the opposite of theta is 3 and adjacent is 4. There are more than one way to do these things. This is the way that I do it. Now, cosecant is just the reciprocal of sine. So I'm not going to go figure stuff out, but it is, if I take the reciprocal, it's hypotenuse over opposite. So it's 5 over 3, or what I did was I just saw the fraction already and flipped it. But I know that if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So hypotenuse is 5, opposite is 3. Secant is now hypotenuse over adjacent because it's the reciprocal of adjacent over hypotenuse. I already have my fraction 4/5, so I flip it to be 5/4. And then the same thing happens with tangent. It is adjacent over opposite. I'm sorry, cotangent is adjacent over opposite, which is 4 over 3. All right? So let's look at another one. If you know that the cosine of theta is negative 12 over 13, so when I try to draw this thing, they don't tell me what quadrant, but I can narrow it down. I've got some angle, and the legs of the triangle, I should say one of the legs is 12. So since we're doing theta like this, let's say, 12 would be adjacent, and 13 would be the hypotenuse. We typically don't put our negative with the hypotenuse. Like, in other words, negative 12 13ths could have been negative 12 over 13, or it could have been 12 over negative 13. Okay? So there's kind of some possibilities here. So first of all, it can't be this option. It can't be that because of our two possibilities here, we never the hypotenuse can't be negative. So we never put the negative on the hypotenuse. We're looking at a cosine, the adjacent side being negative 12. So it can't be this because this side, while the length is 12, it's in the positive direction. So let's look at it if we have an angle of theta that puts us over here in quadrant 2. If my hypotenuse is 13, again, that could never be negative. But now the adjacent side here can be negative 12. So that is a possibility. That orange triangle is a possibility, so I'm going to leave it there. Let's look at another triangle. What if theta went all the way around to here, and we had a radius of 13, and the adjacent side would still be this negative 12 here? That's possible. So which one of these two would it be? Would it be the orange triangle or the green triangle? Well, they give us another piece of information that also has to be true. The sine value has to be bigger than 0. Anytime you see bigger than 0, that means it needs to be positive. So if the sine value needs to be positive, that means this green triangle is out because the signs are negative down there in that quadrant. Quadrant 2 is where our sine values are positive because it's going upwards, right? Whoops, I should keep it orange. The sine value is positive. So this is the winner, this triangle right here. So now I do Pythagorean theorem. Okay, so I've got a side length of 12 for leg. I know it's negative 12, but we're going to square it, so it's not going to matter in terms of finding the length of the sides. Plus our unknown side, I'll call it x for now, equals 13 squared. Again, I know this as a Pythagorean triple, so x is going to be equal to 5. So you could solve the Pythagorean theorem and arrive there, but I know it's 5. Now the question is it 5 or negative 5 this side here? And it's going to be positive 5 because we know the sine value is positive. I really shouldn't have called that x because we're talking about the sine value. It could get confusing. Maybe I should have said y, and then y. It's just unknown. I used it to mean unknown. So we know that this is the y value and it's positive, so I know it's going to be positive 5 because in quadrant 2, our y values or our sine values are positive. All right, so we want to find the exact value of all 6 trig functions. So we've got sine of theta, cosine of theta, tangent of theta, cosecant of theta, again that's the reciprocal of sine, secant of theta, that's the reciprocal of cosine, so I put them on the same line, and cotangent of theta, which is the reciprocal of tangent. So they tell us that the cosine is negative 12 over 13. The sine is going to be 5 over 13. And then the tangent is going to be opposite over adjacent, so negative 5 over 12. So now when we want to take the reciprocal of all these, it's 13 over 5. It's negative 13 over 12. I'm just flipping all these fractions. And negative 12 over 5. There's our answer. Okay, so these get a little trickier when they're not on the unit circle, but this is how we do it. All right. Now let's look at this last. We're going to do the last two here. Okay, so now we're going to say given the terminal side of an angle theta passes through the point negative 2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. It's right there. So the terminal side passes through that. So here's our theta. We draw our triangle, always down to the x-axis. We know that this side length here is negative 2, and we know that's 7 because that's how we got there. We need the hypotenuse before we can start giving the value of all the 6 trig functions. So we're going to do Pythagorean theorem. We'll call that hypotenuse c. So negative 2 squared plus 7 squared equals c squared. So we got 4 plus 49 equals c squared. So we got 53 equals c squared. Square root both sides. C equals the square root of 53. I do not think that's can be simplified at all. 53 is prime. So that's going to be the length of that side, 53, root 53. So that is root 53. So our 6 trig functions, sine of theta, cosine of theta, tangent of theta. The reciprocal of sine is cosecant of theta, because the s and the c, that's how I remember. The reciprocal of cosine is secant of theta. And the reciprocal of tangent is cotangent of theta. Sine of theta is opposite over hypotenuse. So the angle opposite the central angle is, the side opposite the central angle is 7. The hypotenuse is root 53. Cosine of theta is adjacent over hypotenuse. So negative 2 root 53 over root 53. And then tangent is opposite 7 over adjacent, negative 2. Now, for the cosecant, we flip everything. For all the reciprocals, right? These are our trigs. These are our reciprocals. So we flip all those answers. Root 53 over 7. That's why I put them in the same order. Negative root 53 over 2. And negative 2 over 7. This side is done. This side is not quite done yet. This is my answer here. What's wrong with sine and cosine? We can't have roots in the denominator. So sine of theta equaling 7 over root 53 needs to be rationalized. So I can multiply the top and the bottom by root 53. And I get 7 root 53 over just 53. There's no reducing going on there because, again, 53 is prime. So that would be the sine value. And then the cosine value through a similar process would be negative 2 root 53 over 53. This one we're going to talk about in class together.